Hello everyone, I'm Carol from Hikvision. Welcome to the CGNC CCTV course. The topic of this video is IP camera features and applications. Let's start with the learning objectives of this course. By the end of this course, you will firstly realize why we select IP cameras and know about the main advantages of IP cameras. Then be familiar with basic knowledge of IP camera, such as system structure, definition of IP camera. In addition, you will learn about the working principle of IP cameras, including image collecting, coding and compression, transmission and connection process. Finally, be able to choose IP cameras for different scenarios, for example, in factory and in residence. In order to achieve these learning objectives, we will have these 6 parts in this course, including ease of IP, IP camera basics, IP camera main features, main image collecting, coding and compression, transmission and connection process, and finally, the IP camera common application scenarios. We now start with the first part, ease of IP. After we get the cameras, we need to install, configure, and maintain them. And some people tend to think IP solution is difficult and they cannot handle it. However, this is just a prejudice and it's not right. Today, I will show you how easy our IP solution can be, no matter its installation, configuration, or maintenance. In one word, easy from beginning to end. These 3 figures compare IP wired and Wi-Fi solution and analog solution from the point of installation. Because of PoE function, the wired IP solution can reduce the installation label for cables and power supply to promote efficiency. For Wi-Fi solution, without network cable installation, it can also reduce the installation label. We have totally 4 kinds of our IP solution, and every solution has its own way to get quick configuration without difficult IP configuration. Firstly comes popular products, PoE NVR. In this case, what you need to do is only one thing, connecting cameras to the NVR with cables, and then we can see the images at once. It is as easy as analog solution. Even the analog solution needs to power up the camera, but our network cameras can be powered by NVR. Let's together check in this short video. Even if you don't want PoE NVR, but only a conventional NVR, we have another way to help you, that is an auto connection. You just need to connect your IP cameras to PoE switch and activate NVR. The difficult IP configuration can be done automatically by NVR itself. Then, how about our wireless solutions? Do they have easy installation too? The answer is yes. Firstly, if you have Wi-Fi kit, what you need to do to get our cameras work is simple installation, power up, and activation. And what if I only have individual Wi-Fi cameras, but not Wi-Fi kits? We also take it into our consideration. There is Wi-Fi match function, and you can see you only need 1 click on Wi-Fi match and wait for half a minute. All the configuration is done by itself. So, in a word, no matter which IP solution you choose, our configuration can all be easy. As the saying goes, a man without distant care must have near sorrow. We also need to think about whether future maintenance is easy. And I'm glad to tell you IP system is very friendly for future maintenance. Suppose you are in your holiday and suddenly your important client call you to make his cameras work as soon as possible. For analog cameras, you need to go to site and check and fix the problem, right? However, IP solution allows remote check, upgrading, and maintenance. Let us check more in the short video. Okay, now I hope you already recognize the advantages of IP solution, including easy installation, quick configuration, and convenient maintenance. Then we will start to focus on the basic knowledge of IP system and IP cameras. A video security system is a surveillance system capable of capturing images and videos that can be compressed, stored, or sent over communication networks. A video security system is composed of front-end, transmission, recording, and search and display parts. Front-end products refer to cameras. We have analog camera and network camera, or you call it IP camera. IP camera is one kind of front-end products. Other camera types include the analog cameras. Transmission part could be coaxial cable, internet cable, or optical cable. Recording and search part mainly includes back-end products, the NVR or DVR, which can store videos. We also can have storage server as storage device. If you want to manage your system, you also can seek help from the management platform. A decoder can make encoding capability of your system better. The display part is the monitor for you to view videos. For IP camera and analog camera, the system structure is different. They both have camera for video detection, cable for transmission, video recorder for recording and searching. However, for analog system, analog camera cannot encode image data, so analog camera is connected with DVR via coaxial cable. It transmits analog signal. The image data is encoded in DVR. But for IP system, IP camera can encode image data. Therefore, encoded digital signal is transmitted to NVR via internet cable. Now, let us see this IP camera together. Inside it, there is lens. You can see the lens here. But inside, there is also sensor. It can be CCD or CMOS sensor, or ISP, image signal processor, and DSP, digital signal processor, and related circuits. The light from the target subjects passes through the lens, gets collected by the image sensor, and forms weak electric charge. Under the control of related circuit, accumulated electric charge moves and then processed and compressed in ISP and DSP. This is the working principle of IP camera. Finally, the signal transmits over the network. Well, I believe now you have better understanding about the IP system and the definition and working principle of IP camera. We will then start to talk about the main functions and the working process of IP cameras. They are image collecting, coding and compression, and transmission and connection. The first topic is the image collecting, which is the most fundamental function of IP camera. Let us firstly make an analogy of human eye and the camera to learn more about the theory of imaging collection process. On the real inner surface of the human eyeball is the retina. When we're trying to see something clearly, our eyes is properly focused. Light from objects outside is distributed and imaged on the surface of retina. Then our brain will process the image, so we can get a visually perceptible image. For IP camera, image sensor is similar to the retina of human eye, and ISP, the image signal process, is like our brain. Okay, we now know how camera collects image like human eye. For image collecting performance, we have two groups of features. They are image features and intelligent features. We will start with image features. It is very important and fundamental for a camera to take great quality images in no matter what conditions, right? IP cameras have many features to guarantee the image quality. In this part, we will talk about three key features, including the resolution, WDR, and the low light performance. The quality of image can be described by resolution. All digital images are made up of the smallest individual component called pixels. Each pixel has a specific color and intensity. The total amount of pixels in an image is referred as the resolution. At a higher resolution, you can see the camera can capture finer details in the scene as shown in this image. However, higher resolution also leads to larger requirements of storage space and transferring bandwidth. For some application scenarios requiring more image details, you should adjust your cameras to a higher resolution. The difference between the darkest and the brightest parts of a scene is called dynamic range. If the dynamic range is wider than the capabilities of the camera's sensor, we will see areas of deep black and bright spots at the same time. As shown in the photos below, the entrance of this building is overexposed, and the face of this person cannot be seen clearly. Some cameras feature a wide dynamic range mode. We call it WDR. It is a technology delivering perfect image quality without detail loss when facing strong lighting contrasts. Then, cameras own various features to guarantee image quality in low light environments. Just like the continuous improvement of TV technology from the black and white to color, people have never stopped chasing quality imaging even in darkness. Advanced technology have been developed to improve the data quality from the source of video image with rich details and real color performance at nighttime. The first feature is called black and white mode switch. We can tell from these two pictures. The image taken during daytime is colorful, but the image taken during nighttime is black and white. Why we make this difference? To understand the reason, we need to know what is ICR. Before ICR, we firstly talk about an interesting phenomenon. The wavelength of light that human eyes can see is limited as shown in this picture. So we can only see the visible light, but not ultraviolet and infrared light. So these lights are invisible for us. However, camera can see all visible light, ultraviolet light, and infrared light. Therefore, an IP camera with day and night switch function has an automatically removable infrared cloud filter. We call it ICR. During the daytime, ICR cut these invisible lights off and only leave these visible lights. so the generated image is just the same as human eyeballs can see. But during nighttime, we do not have so much light in the environment, so we collect as much light as possible, including the ultraviolet and infrared light, to generate image. Therefore, we will get a black and white but very clear image. Traditional cameras uses infrared light as a supplement light so that cameras can capture images in darkness. And EXIR in this slide stands for Extended Infrared, a technology that improves the security camera visibility in dark environments. It reduced the center brightness of image and creates a rectangular pattern with even light distribution, as shown in these two pictures. The IR range of a security camera is usually between 10 to 30 meters. With the most advanced EXIR, the camera can see an at most 60-meter distance. IR technology provides supplement light at night, but captured images are black and white image. Therefore, if we need color images in low light environments, we still need other technology. In this slide, we take dark finder camera from hikvision as an example. We compare these two images captured in the outdoor parking lot at night. We see that in the left-hand side image taken by the conventional camera with IR light, we can see there is a car in the parking lot, but we cannot see the background and also the license plate number clearly. However, we see in the right-hand side image, the color is much brighter, so we can see the background clearly, and if we zoom in, we can recognize the license plate number. Therefore, we see camera powered by dark finder has brilliant performance in low light environments compared with conventional cameras. Although dark finder camera has better performance than conventional camera in low light environments, when the environment light level is even lower, it cannot provide clear color image as well. So we still need to use camera equipped with EXIR supplement and get clear black and white photo as shown in the left-hand side image. If we want color image at this extreme condition, we require more advanced technology. We take color view camera from hikvision as an example in this slide. It leads to a revolutionary improvement of image quality in low light environments. Although in completely dark environments, the warm supplement light color view camera still can capture clear and color pictures and videos, as shown in the right-hand side image. Solving the problem caused by low light environments, no matter which types of products, such as dark finder or color view, some theories are similarly applied. From the perspective of hardware, large size of sensor increases sensing area, and large aperture let more light enter camera, so generated image is brighter. Compared with FSI, front side illumination sensor, and BSI, backside illumination sensor has higher utilization efficiency of light. Therefore, BSI sensor is used in low light cameras. From the perspective of self-adaptive ISP technology, camera applies smart gain control, auto non-linear image enhancement, multiple exposure, and 3D DNR, which means the digital noise reduction, and other technology to optimize the image quality in night. In addition to providing high quality of image, IP cameras do a lot more. Built-in intelligence enables cameras to perform a number of tasks to reduce the workload for operators and increase the surveillance efficiency. So in the next part, we will talk about intelligence features for image collecting. Firstly, let us think about why we need intelligent functions for camera. When we use camera to capture and record for security purposes, we expect to observe and find some events and motions in a video stream, such as the accidents or other threats. Without intelligent functions, the traditional approach is to look for a specific event from hours of footage playback, which is very low efficient, time and labor consuming. Therefore, intelligent functions such as the motion detection and the parameter protection are used in security cameras and recorders to make it easier for operators to locate the targets and secure their property. The basic theory is shown in this diagram is that when movements happen in the scene, then cameras will detect the image change and trigger related events. Motion detection function is widely used in security applications. Motion detection 1.0 is what we call for traditional motion detection technology. It detects basic events triggered by pixel changes in the video. Therefore, it is very insensitive and easy to use. Any pixel changes can trigger motion detection events. The drawback is too many unimportant notifications caused by falling leaves, flashlight, birds, and so on. When users need to find some specific events, they need to find it from these too many events, so the efficiency is still low. Okay, in this video demo, you can see motion detection is triggered by pedestrians, birds, leaves, but most of them are not expected target in security CCTV system. In order to solve the problem caused by too many unimportant events triggered by motion detection, new generation of motion detection 2.0 is developed. It can realize human and vehicle target classification while deep learning algorithm. Focus on human and vehicle, but filter out other unrelated targets such as animals, rings, light change, leaves, and so on. Reduce the disturbance alarm. Motion detection 2.0 is upgraded from traditional motion detection 1.0, newly adds human and vehicle target classification. Therefore, motion detection 2.0 also has advantages of high sensitivity. All small changes can be caught in the video. In addition, human and vehicle target classification can quickly find the target. Equipped NVR with human and vehicle target classification, the video clips, like shown in this image, with human and vehicle targets are marked in playback. So, users can efficiently find important videos and skip uninterested footage. Human and vehicle target classification is enabled by default, so it is also very easy to use. Let us experience the advantages of motion detection 2.0 in the following video. In order to meet specific requirements in a variety of security systems, there are more intelligent functions for parameter protection. so that instant alarms can be triggered when a specific kind of behavior is detected, including line crossing, intrusion, region entrance, and region exiting. The main difference between these application scenarios is the way and direction entering or leaving our protective area. Here, we take line crossing as an example and show you how it works in the following video.
Danger, please keep away. Danger, please keep away. Danger, please keep away.
How perimeter protection works. We call the theory as background modeling technology. Background modeling technology creates a static background model in the monitoring area as shown in this picture, and the background is the road with any pedestrians and the vehicles. At the same time, detects and records the moving objects as a foreground model, like shown in these two figures. In this photo, there are one car and two persons. Then camera will analyze the color, the shape, the size, and the type and the path of these moving objects. And according to the rule we cite, such as enter, leave, appear, and disappear, decide which alarm is triggered if the moving objects reach the alarm threshold. License plate recognition cameras are usually used in road and entrance and exit. Camera with this ability can achieve plate capture and recognition while deep learning algorithm. Here is a video to show us how this type of cameras are applied.
This advanced tool enables security personnel to manage vehicle entrances and exits more efficiently. In the Watch House mode, all entrance and exit related information is compiled. It displays images and real-time videos of passing vehicles, supporting manual verification and efficient history tracking.
Okay, after collecting the image data need to be coded and compressed. We already know how images are collected by lens and sensor, but we know we get the image data as analog signal. In IP camera, this analog signal needs to be converted into digital signal. This process is called encoding. Digital video is then compressed to use lens bandwidth for transmission and to save the storage space. Let us further learn about the basic principle of compression. When IP camera records video, it captures a large amount of redundant information in the video data. For example, as shown in these capture pictures in one single video, this man moves, but the background environment keeps constant. So we do not need to record the static background in each frame, right? So the static part is regarded as the redundant information. Compression removes this redundant information from video data. And different scenes can be compressed with varying results. A busy scene with a lot of motion will be more complex to compress, which results in more bandwidth being required. There are various compression methods, including intra-frame compression and inter-frame compression and entropy coding compression. After coding and compression, digital data is then transmitted to the video recorder, software platform, cloud, and so on. So we talk about transmission and connection of IP camera in next part. Transmission is based on ICP-IP network model in IP system. For different transmission protocol, they have different application protocol for application layer. There are many standard application protocols, such as the FTP, Telnet, HTTP, SIP. However, the security industry has many industry-defined application protocols that can be applied in IP cameras from different companies. So we usually see the standard protocol in security industry as well, such as ISAP, WIF 2A1A1 1400. Every security device company may also has their own private protocol that is only applied in their own devices. We take WIF protocol as example of standard protocol in security industry. The WIF stands for Open Network Video Interface Forum, which is established to develop open industry standard. A standard protocol is very important to guarantee seamlessly interconnect between products and platforms from different brands. A WIF service includes the device management, media, event, PTZ, image, storage, and video analysis services. For private protocol, we take Hikvision Networks SDK protocol as example. Management software and system platform connect with front-end devices based on the SDK database. Then we are connected to front-end devices by utilizing Hikvision Network SDK protocol. Network SDK protocol presents as HCNet SDK to outside connection. It is based on Hikvision's private ISAP protocol and covers all functions of Hikvision products. For connection between IP camera and cloud, there are two main types. The first one is devices adding to cloud via public or LAN IP address. When you want to view live videos and click the icon in app on your phone, a signal transmits to the device, and then the video stream transmits directly to your phone. The whole process does not need to wire the DAS server. And the second method is adding camera to cloud by P2P adding. It means peer-to-peer. We have two scenarios. The first scenario is VTDU, the media stream transferring scenario. No matter sending signal or get video stream, we need the transmission via the DAS server and stream media server. The second scenario is P2P, a direct video stream pathway is built between the device and your phone. After the DAS server knows the address of both your phone and the device. So far, we finished most of contents in this course. We already understand the principle of working process and IP camera, and for this process, there are many key features of IP camera selection. Therefore, in the last part, we will together check the real application of suitable IP cameras in different scenarios. Firstly, from the perspective of IP cameras features, we just talked in the part of image collecting, remember? And the cameras featured with wide dynamic range function can deal with strong backlight in the areas near entrance or window. IR, darkfighter, color view cameras have great performance under dark environments. And for intelligent functions such as the license plate recognition, the region entrance and exiting, and the intrusion detection can satisfy specific requirements of security. IP camera also have plenty of appearance for wireless requirements in installation scenarios and location. Turret usually used in most indoor scenarios, and bullet cameras are preferred in most of outdoor scenarios. Fisheye is designed for large indoor scenarios because it can provide wide field of view. What if we want to have a large view in outdoor environment? We can select the panel view cameras. We also have some special appearance cameras. For example, in some hidden and small installation room, such as ATM, we can employ the covert cameras. Anti-corrosion and explosion-proof cameras are designed for their special application scenarios. Okay, let us have 3 typical scene analysis. The first thing is in factory. What's your first idea about what cameras should be used in factory? At the entrance of factory, what type of cameras is suitable? We can use license plate number recognition cameras, so we can monitor and control the entry of vehicles and guarantee security. And for perimeter, camera featured with intrusion detection can detect the intruder, break in, and protect the factory. And some factories may have a high-risk explosive area. In this kind of area, for example, if explosion-proof camera is utilized, continuous monitoring can be guaranteed even when explosion occurs. The second thing is in everyone's daily life. Residence. The application of IP camera in this scenario is simpler. The most widely used function is perimeter detection. Selection of the intrusion detection or the line crossing detection depends on the ambient environment and installation condition. Let us check video for this residence scenario.
Attention please, the area is under surveillance. Attention please, the area is under surveillance.
The third thing is retail stores. At the gate, we also can have line crossing camera for real-time lifeguard. Then, when you as a customer enter a market, what you usually hear? The warm welcome or sales information. If we install a camera at customer's reception with region entrance and exit detection and upload customized audio broadcast, once customers are detected, audio broadcast will trigger automatically. And as the owners of stores, they wish to monitor which area and which products are more popular. Then they can have fisheye camera to get a panorama view and get a visualized heat map for popularity analysis. Okay, that's all content for this course. In this course, we talk about the definition and working principle of IP cameras, and also the key features and how IP cameras is selected for different application scenarios. Thank you for listening and hope we can meet again.